GA max size, but I'm unable to extend it. Please tell me why it's happening and a solution for it. There's not enough information there. You can't answer this question. You don't know the operating system platform. You don't know if it's 32-bit, 64-bit. You don't know if the machine is completely out of memory. You don't know if they got a problem starting out with semaphores as opposed to a memory problem. You have no idea what is causing this issue. The way I answer that typically is, my car won't start. I'm not going to tell you anything else. I'm not going to give you any of the error messages I see. I'm not going to give you the conditions. My car won't start. When you can answer my question and tell me why my car's not starting, I can tell you why what is happening to you is happening. And I say this a lot. There's another question. I took a backup on a standby database. I want to do some things. Basically, it boiled down to, but I failed. So they told me some stuff, nothing useful. They said, but I failed. So I have to say, but my car won't start. This is a wonderful site. Always start with flattery, right? Because that will get the answer to the question if you start that way. I want to know how to export, import successfully things that have an XML type as a column. I tried unsuccessfully. The log file says export terminated. All the other columns in the table are exported except for the specific XML type column. Please tell me how to accomplish doing this. That falls again into my favorite category of question. My car won't start. Why not? There's no information here telling me how to reproduce it, what the error message that accompanied this was. As an export was scrolling along, printing out what it was doing, it printed out an error message, but he chose not to give it to me. So I don't know what was going wrong. So I get this a lot, over and over again. For this presentation, all I did was I searched on AskTom for car won't start in quotes. And I just took the first couple, but there's a lot of them. This one I sort of like. The person gave me a lot of information. If you glance at this, it looks like they gave me lots and lots of details. Unfortunately, the question that they asked has nothing to do with anything they gave me. This error message has nothing to do with the question at all. It's completely unrelated to it. So I changed my answer. I said, I'm going to give you a lot of data. I have a car. I drive it on this highway. I drive at this speed. I drive for this long every day. I turn right, then I turn left. I park the car. Now my car won't start. Why not? None of the stuff I gave them is going to help them diagnose my problem. So when asking the question, pretend you were asking this question of your mother. Give them that kind of detail. The person you're asking the question of doesn't work where you work. They don't use the same words that you use. They don't use the same acronyms, abbreviations that you use. And most importantly, they haven't been staring at your problem for 7 hours like you have. So they don't have all that inside knowledge that's in your head. Be very explicit. Think it all the way through. Whittle your example down to the smallest possible case. I've had somebody give me 50,000 lines of pro C code. C code. It says it crashes. It segmentation faults. It core dumps. It does not run. Why? I have no idea. There's 50,000 lines of C code here. It could be something over here causing it to crash over there. You're going to need to break the problem down much smaller. Help us reproduce it so that we can find out what's going wrong. Many times, when I take a big problem that I'm having and I try to isolate where it's broken, I take away everything that doesn't affect it, I find what I did wrong by making the example smaller and smaller and smaller. My mistake becomes obvious at that point. So we make those small test cases. Think about those implied constraints. Remember that SMS text messaging, limiting to 140 characters. One of the big problems I see is that we write way too much code. We're programmers in many cases. We're developers. We get paid to write code for money. That's what we do for a living. We should get paid based on how little code we generate, not based on how much code we generate. Because the less code we generate, the less bugs we're going to have. I have a saying, more code equals more bugs. Less code equals less bugs. So here was an example. I like this example because it's actually in SQL Server. It's not Oracle. So this is demonstrating that this writing a lot of code problem exists everywhere. Everyone has it. So here's a stored procedure. It has lots of variables. It starts with a select statement. And if we look at this select statement, we can see we're selecting a variable equal to the max of a column from a table where a column equals, that's funny, it's the input to the procedure. So what does that select statement do? It's always going to retrieve at least one row, because if I select a max without a group by, I'm going to get at least one row. If this record exists, if this where clause finds a record, I'll get back a non-null value. I'll get back a value. If that record does not exist, I'll get a null back. Apparently what they're doing is they're trying to find out if a record exists in the table. So now we understand that. The second SQL statement, select first name, last name from, well, that's the same table over and over. I see this table being referenced a lot down here. So we're going to select from this table where that column equals that variable that we just selected out. So I'm already seeing a way that I could probably take this and collapse this two SQL statements into one SQL statement, right? Because I want to check if a row exists in one table, and if it does, I'm going to query another table for that record. I'm going to get the first name and last name. Now I'm going to take this same table and I'm going to query it again with the same where clause. Because in the first query, I got the first name, last name. In the next query, I'm going to get their email address. And further, in the first one, I use this need to go to the function is null, to make sure that there's no null values there. Then we come down and we get the email address, and then we do another query. Well, that's interesting. That's the same table again, with the same where clause, just a different column. So now I have 3 queries to get 4 different columns out of this table. But this time, they decided that is null is sort of boring. It would be better if we could write even more code. After we fetch it out, we'll look and see if it's null, and if it is, we'll do something. This stored procedure goes on and on and on, and it's always the same table, and always the same where clause. What do you think happened in this procedure? It started with, I'm a procedure that gets the first name and the last name. And then somebody said, oh, we need the email address. Oh, that's an easy fix. I'll just add that in. And they added the second query in. Oh, we don't need just the first name and the last name and the email address, but we need the zip code too. Not a problem. I'll just add a 4th query. This is why databases perform poorly, right? In order to get one record, they hit this table over and over and over again. And the developer's reason? It's better this way. You get a lot more control over things, right? And so this is something I see over and over and over again. Look for ways, if you want to tune in here, look for ways to remove code. I could get rid of all of this code. This stored procedure should be one SQL statement, no more and no less. And nobody can convince me otherwise. Right? So look to write less code. You'll have less bugs, and you'll have better performance. Here was another example. This one is in PL SQL. So here was an interesting procedural approach to creating a new record. We sent